Hi guys, my name is Anurag. I'm mainly going to focus on the heats of reaction aspect of chapter 13 in this video rather than the fuels, which was covered in part 1 of the video. So, a reaction is a chemical process in which substances act mutually on each other and are changed into different substances, or one substance changes into other substances. Now, if the amount of heat produced in forming bonds is greater than the amount needed to break bonds, heat is given out and the reaction is said to be exothermic. If the amount of heat produced in forming bonds is less than the amount needed to break bonds, heat is taken in from the surroundings and the temperature of the reaction mixture decreases. Here's the definition for the heat of reaction with the important keywords of the definition underlined. The heat change in a particular reaction depends on what amounts of reactants are involved, and this is indicated by the balanced equation. It's also important to take note that the heat of reaction for exothermic reactions is always negative, and for endothermic reactions, it's always positive. Okay, so let's try a question. When 100 centimeters cubed of 1 molar nitric acid solution react with 100 cm cubed of 1 molar potassium hydroxide solution, the temperature rises by 6.7 kelvins. Calculate the heat of reaction. The formula we'll use is Q is equal to mc delta T. In this formula, Q is the change in heat, m is the total mass, c is the specific heat capacity, and delta T is the change in temperature. So you substitute everything into the formula to get 5.628 kilojoules as your heat change. Now to find the number of moles of HNO3 in the system, we use this formula. Volume in liters multiplied by the molarity is equal to the number of moles. We have 0.1 moles of HNO3 in the system. If you recall the balanced equation, it required 1 mole of HNO3. Since 0.1 moles produced 5.628 kilojoules of heat, 10 times as much heat would be produced for 1 mole. Therefore, the answer to the question is minus 56.28 kilojoules. Now for a few definitions. Bond energy is the amount of energy needed to break bonds. The heat of combustion is the heat change when a substance reacts with oxygen. Heat of formation is the heat change when a mole of substance is formed from the elements in standard states. The law of conservation of energy states that energy cannot be created or destroyed, only changed from one form to another. Now we're going to talk a bit about Hess's law and then do a question on it. So, Hess's law states that the heat change of a reaction only depends on the initial and final states of the reaction, and the route which the reaction took to get to the final state doesn't matter. The formula at the bottom states that the heat of reaction equals the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. So here's the question. Calculate the heat of combustion of methane given the heats of formation of methane gas, carbon monoxide gas, and liquid water are minus 74.4 kilojoules per mole, minus 393.5 kilojoules per mole, and minus 285.8 kilojoules per mole, respectively. The equation is at the bottom. Okay, so hopefully you remember this formula. Heats of formation of products minus heats of formation of reactants is delta H. Now you substitute everything into the formula and the answer is minus 890.7 kilojoules per mole. It's an exothermic reaction.